Hey, what's up everyone? I'm Kunal again with this new video for you guys. I hope you like my last video, and in last video, if you remember, I shared few topics with you guys for your upcoming interviews, and today I would like to discuss one topic with you guys, and that is the Java memory management. Why I chosen this topic? Because Java memory management plays an important role in the efficient execution of Java applications, and if the developer aware about these models, then he is capable to avoids the problems like the memory leakages, performance bottlenecks, etc. Let's begin the discussion then. So your Java memory models are basically divided into three basic components. First is the heap memory, second is the stack, and third one is the meta space. So let's start with the heap memory. So heap memory is the widely used part of the Java memory model. So whenever developer declares anything using a new keyword, that object gets memory allocated at the time of execution in the heap. So heap memory basically have the two generations in it. One is the young generation and second is the old generation. So whenever any new objects get created, that object goes in the young generation, and whenever garbage collection life cycle executes, so the objects capable to survive in that garbage collector cycle, those objects are considered in the old generation of the heap memory. Now second one is the stack memory. So stack is used to store the local variables and the method call information in it. Each thread in Java has its own stack, and that stack is capable to grow and shrink automatically. So your stack is used to store the primitive data types like boolean, int, float, etc., and stores the method called references. Let's understand this stack with an example. Suppose you have a main method having a few variables, declare int a equal to something, int b equal to something, and int result equal to multiplication. Multiplication is a method here, so we are calling another method here. So multiplication is a two parameterized method, a comma b we are passing there. So whenever we call this multiplication method, the Java memory creates the separate stack frame for this method, a separate stack frame for the multiplication method. So multiplication have let's say one variable in total, which is multiplying a and b value. So that total have a separate stack space and in the Java memory model, and the variable resides in the main have a separate stack frame in the memory model. So this is how stack work in the Java memory. I hope you understand it. Now let's begin with the our final component, that is the meta space. Meta space freshly introduced in the Java 8, and meta space is the replacement of the permgen or permanent generation memory. So your meta space stores the class metadata, constant pool information, and the bytecode in it. So why metaspace is so popular? Because metaspace is capable to manage its space automatically. Whenever it required to increase, it gets increases. Okay, because your metaspace totally depend on your underlying OS. Why permgen is get replaced in the Java 8? Because permgen have a very limited memory area, and once the permgen memory area start getting full, your JVM frequently calls the garbage collector, and calling garbage collector frequently is very costly operations. And also whenever the space in permgen start getting full, the application has to deal with the out of memory errors. So this is why meta space came up in Java 8 and resolve the issues related to the permgen. So still, while working on the meta spaces, you have to keep eye on it, because it is also unlike the heap and the stack, it does not have a flexible memory. It can't shrink itself. It keeps on increasing. So you have to keep eye on your ongoing operations in the meta space. I hope you like my videos. Post your comments in the comment section. Like my video, share my video with your friends. Thank you so much. Bye bye. Take care.